All right. For your information, everything from now on is recorded.
Okay.
You better say something clever.
I still have a difficulty in trying to associate photons and light, because in the discussion they use photons and light interchange. That's it. I can't think of them being two particles. If you do understand what I'm trying to get.
Yeah, the spooky action at a distance is the problem.
Yeah.
Yeah, it's look, of course, you know, as things speed up, time slows down. And of course, a photon travels always at the ultimate speed limit. So therefore, time has slowed down to zero for a photon. That's as simple as that. Exactly why or how, I don't know. Is that the why or is it the how? I'm not sure.
Yeah.
Yeah. Derek? Can you hear me? Not quite sure. I once read in science fiction. I used to read a lot of it. You know, the way they describe a kind of, as you fall into a black hole, then time kind of stretches as you approach the speed of light. So they always said that as you fell into the black light, time would stop, so that you would be frozen in time. Now, is that the kind of thing he's talking about, that light, that time stretches so that this, because the photon is traveling at the speed of light, time stretches to such an extent that it didn't exist at all?
No, you know, we did a whole course on special relativity with John Haynes. We spent a few months doing it. It was presented by Brian Greene, and according to that, we all came through the course and understand how special relativity works, but it still boggles my mind. You know, the thing is, at the event horizon, it's actually, I think the Russian name for a black hole is a frozen star. Because at the event horizon is actually the spot where time slows down to zero. So
Derek,
that is also, you've got to think, it's also for the observer from a distance, not for the person that's actually falling in. For him, everything is normal, except that it's being torn apart by the gravitational force. Pierre, you were going to say?
No, I said the time stands still for an external observer.
Yes, yes. We've got to remember that. So this is one of the things that confuses me.
For the person falling into the black hole, everything is absolutely normal.
Yeah.
Until he gets stretched apart by a differential gravitational pull between his head and his feet. Just a brief comment on the video. I think it is very well presented. It illustrates the particle-wave duality, I think, inherent in quantum mechanics. And probably the simplest description, I can't remember who it actually was. It might have been de Broglie that said, when a photon travels, it behaves like a wave. When it interacts, it behaves like a particle. And I think that's the simplest way to understand, or my understanding of particle-wave duality.
Yeah, I just always remember how Pierre Hugo always used to describe it. He said, no, it's a standing wave. And to me, that's really appealed to me. You know, it's like it is a wave which looks like a particle because it's reached some sort of a balance where it appears to be a particle, but it's actually a wave. So that's gives one a sort of an analogy which one can use to try and explain it to yourself. Yeah, and also, you know, the speed of light being the universal speed limit. If the wave is oscillating at the speed of light, then nothing else can be sort of, it sort of, it occupies a bit of space where nothing else can exceed that speed of light. It just cannot be done. So that is also part of what makes it a particle, I think.
Derek, at one stage, again, this is science fiction, they used to speak about tachyons or tachyons, and these tachyons were supposed to travel faster than the speed of light. Look, I know it's science fiction, but these days science fiction sometimes becomes true. Any comment?
Pierre, a tachyon is actually a proposed actual particle, isn't it? Not science fiction. But whether it can travel faster or supposed to be able to travel faster than light, I think that might be science fiction. Pierre, do you know what a tachyon is?
I plead ignorance, but I agree with your statement. It can go faster than the speed of light.
Yeah. So, yeah. Okay, I think one will have to Google that. But I think it's definitely one of those proposed, unless I'm thinking of something else, one of those things to explain, I don't know, dark matter or something like that. I might be thinking of a different particle there. But it's one of those sort of, it's a conjecture, but never been proven.
The photons used in radiation for like cancer treatment, how does that actually work? Do they focus many photons onto one point, the same as the original sort of radiography, or is it just I just cannot ever understand how something with that speed, with no ability to have time, actually fixes up can kind of target a tumor in your system.
Yeah, look, a photon is just a packet of electromagnetic energy, essentially. I don't know if it has to be actual light. I mean, light, as we describe it, is a small part of the electromagnetic frequency. I think you can have actual photons which are not light as we know it in the visible frequencies that we are aware of. Pierre, is that right or wrong? Can you have X-ray photons? I think you can. And gamma ray photons? You can, I think.
Yes, you can. Across the spectrum, the
Yeah.
whole electron spectrum.
So, I mean, yeah, so radiation, X-ray radiation is one thing. I don't know what you're talking about, Mick, but there's a different type where they have a positron gun. My son was working on this in a cyclotron, where they actually they do special treatment on tumors which cannot be removed by surgery because it's too complex, and they actually target I think a positron or something at a specific energy. They give it a very specific energy, and it travels to a certain depth and then heats up when it reaches a depth. They give it a slightly different energy, and then they actually create a 3D image of where it will hit, and in exactly the same image as the 3D image of the actual tumor, so that they actually sort of target the heat into the whole tumor, and by doing that they can shrink the tumor.
That makes sense, yeah, because they put a specific mark, a couple of them, and then the whole alignment of these incredible kind of machines is towards those actual marks. So presumably there's a kind of crossing over which heatens or causes some sort of explosion of those two things.
Yeah, it's almost like a 3D printing in the tumor with the thing, by changing the parameters slightly, the direction of the beam and the depth that it will trigger. They can cover a whole tumor in 3D.
Thank you.
So yeah, it's amazing. what they can think of and what can be done. I don't know whether the one at Fora is still working though.
I just Googled tachyon. It's a hypothetical subatomic particle whose velocity always exceeds that of light. No verifiable experimental evidence for the existence of such particles. But in 1967, a paper that coined the term, Gerald Feinberg, proposed that tachyonic particles could be made from excitations of a quantum field with imaginary mass.
Oh,
Yeah,
That's-
that's more science fiction than science, I think.
yes, sounds like down there.
It's playing a bit fast and loose with physics as we know it.
It's good to hear that already James Webb is validifying some of those theories. I didn't quite understand what though. Did you understand what it was that James Webb had kind of almost, as I say, validified one of the theories that they had?
Yeah, that was not something new to James Webb. I think, Hubble had also taken many of those images where you have those sort of ring-shaped, where stars and galaxies, the image of them becomes like a ring. That's because of the magnification effect by mass in its path of the light on its way to us, our eyes.
The
So, yeah.
curvature of space
Yeah.
as a result of huge concentration of mass.
Yeah, so a thing which would have been in a point, it sort of almost distorts to where it forms a ring or part of a ring. As it travels around on both sides. So the light from a point is traveling around the mass, the concentrated mass in two directions and comes together in a ring where we see it. So you get those concentric circles. Obviously the mass is in the middle of that, the center of that circle. And sometimes there seems to be nothing physical there. So that's what they reckon. Now that's dark matter there. And also they can actually calculate the mass of stuff fairly accurately from the way that the light is distorted and so on.
Fritz Zwicky did it in the early 1930s. And he, I think, was the first one to coin the term dark matter.
Okay.
Because
Zwicky.
he said there must be more mass in, I can't remember which cluster of galaxies than we observe in visible light. But that's early 1930s.
Yeah, so yeah, light is still. I mean, they've gone through what we know about light in this one, and I think they did it very well, as you said, Pierre. But I think there's still a lot of mysteries about it. A lot of stuff we still, if we could solve some of those mysteries, we would be light years ahead in our understanding of physics. But
Derek, you used the term, we understand what happens, but we don't understand why a lot of things are the way they are in nature.
yeah, same with gravity. I mean, Einstein described it very well in his theories, but we know how it happens, and he described the mathematical formula with which you can use to calculate the effects and so on. But we don't know why. And if we can find that out and understand that, that'll be a major breakthrough. And I still think gravity can be quantized. A lot of people are beginning to have doubts. So yeah, lots of Nobel Prizes for you guys to win out there. When was it, in 1890 or something? Some scientists said, all right, now we know everything, there's nothing more to learn. I think it was when Maxwell had sorted out electromagnetic formulas and stuff. All right. I hope you enjoyed that. And I think the series following on from now on, next few months are going to be also very interesting. I was, by the way, watching a fairly interesting short video of about 15, 18 minutes by one of the guys that we've seen before, questioning whether there ever was a big bang. And the way he described the science behind, trying to evaluate the question, I think was pretty good. It was quite intensive. I don't know if we can fit that one in sometime, but it's quite a good video.
That's a good idea.
Maybe we'll put it in between one of these sessions. I'll discuss it with Peters and Pierre, see what they think. All right. Everybody's getting hungry. You want no more questions?
Thanks, Derek.
That's it,
That was well. Good night, everyone.
Yes.
Yeah.
Thanks, Derek. That was a fascinating video. Thank you.
Cheerio, everybody.
Okay. Next time we try not to be
Cheers.
late.
Good
Cheers.
night.
Bye.
There we go.